Today we are going to see regular expressions. And in regular expressions, before going into regular expression, there exist three basic operators for all the languages in theory of computation. That is, the algebra for languages consists of three basic operators. The first one is the union operator. So the union operator is represented by means of the plus or the vertical line symbol. The second one is the concatenation operator. The concatenation operator is represented by means of a dot or a small circle. The third one is the clean closure operator or the star operator. Okay, so these are the three basic operators that serves as algebra for all the languages. Now we'll go to regular expressions. So what is a regular expression? Basically, we know that an expression, or for that matter an arithmetic expression, consists of a set of operators and operands. So if you have an expression like a plus b star c, here a, b and c are operands, whereas plus and star are operators. Similarly, regular expressions are used to form regular languages, which is the type 3 language. We know in Chomsky hierarchy, we have 4 type languages. Here type 3 language is the regular language, and so regular expressions belong to the regular language. Okay, so first we'll see some of the regular expressions first. So talking about regular expressions, if I have a language A, so usually the language is represented by means of a single brace, okay, or the flower bracket as we call it. So this is a language. So this is a regular language means then A is a regular expression. Okay. The second point in regular expression is, if this is a regular language, this epsilon stands for empty set. Epsilon stands for empty set, means there is there are no strings or words anything present in this language. Okay, so the language basically consists of strings or words, so nothing is present in this set, so we call it as an empty set, which is represented by means of so nothing is present in the language, and there is only an empty set, that is epsilon is used to represent the empty set. Then epsilon is a regular expression. Okay, so I'm also in a language, what are all regular expressions? I'm just listing one by one. The third is this symbol, or you would have seen this symbol somewhere. So these both stands for empty language. Empty language. So they are both regular expressions. So the symbols itself stand for regular languages. Okay, so they stand this symbol or the null symbol, or you call it somewhere in some places we call it the null symbol. This stands for the empty language. Okay, then fourth is, if R1 is a regular expression and R2 is a regular expression, then R1 plus R2 is a regular expression, which means that this plus stands again here for the union operation. I will be explaining how to evaluate the union operator. So here the point is that if R1 and R2 are two regular expressions, then the union of these two regular expressions is again in turn a regular expression. Okay, so the union of regular expression is or you can call that regular expressions or regular languages are closed under union operator. So the closure properties, I hope you know the closure properties of regular languages and different automatons. So this here, the regular languages are closed under the union operator. You can also represent this by R1 slash R2. Okay, so the fifth point is here R1 dot R2. So R1 dot R2 here, dot may be present or simply R1 R2 will be present. So this stands for concatenation. So if again R1 and R2 are two different regular expressions, then R1 dot R2 is again another regular expression. So this is concatenation here, concatenation. Okay, then the sixth point is, R star is again a regular expression. So if R is a regular expression, then R star is a regular expression. So the star, as you know, is the clean closure operation. So what is a clean closure operation? So if I say one star, what is the meaning of one star? The language that is represented by this regular expression, okay, or the strings that form the regular language can be derived as zero or more occurrences of this one. So if I so zero or more occurrence means one may be either present in the language, or it may not be present, or one may be present one or more times. So what are the strings, possible strings? So there could be an empty string, there could be one occurrence of one, there could be two occurrences of one, three occurrences of one, and so on and so forth. So this is clean closure operation. So if R is a regular expression, then R star is again a regular expression. And again, if you represent the regular expression within brackets, or what you call the parenthesis in computer terms, so again this is a regular expression. So these are the different points that are to be noted as far as regular expressions are concerned. So we'll go into solving some regular expression examples. Okay, now we'll see regular expression examples, and before that I also want to note some more points here. Okay, so the strings that you are forming using regular expressions. Now let me tell. For in a language, as we saw in a language, the language could be empty. It could be an empty language, or there could be present strings of length 1, of length 0, of length 2, length 3, or at most 1, or at most 2. Let us see examples for that. Okay, now usually a language is represented by means of the letter L. A machine is represented by, we know that it is represented by means of the letter M. Regular language or regular expressions are represented by means of the letter A. And the input to any language is represented by this E, or the what do you call, the sigma symbol. Okay, so if I say sigma A comma B, means always sigma always represent the alphabets which are present in a particular language. Okay, so alphabets means these alphabets are used to form the strings in a language. Like in English, if you have a word like animal, okay, we have a word animal in English. So what are the alphabets that are used to form the string here? A, I, L, M, N. So these other. So I can say sigma A comma I comma L comma M comma N belongs to English language. Is a subset, or I can say belongs to the English language. Similarly, here what we are doing, we are representing input alphabets, now the characters that are present in the language by means of the sigma symbol. Now suppose let us assume that in a particular regular language we are going to use two letters, that is A and B, or two characters A and B. Now it is an example of a no string language, no string regular language. So no string regular language is simply something within this. So here no element is present. Okay, so it is a here we can term this as a what do you call, this is the empty language, right? So this is the no string language. This is one example of a this is the example for a low string, otherwise you can't write it otherwise. Now example for length 0 string. Okay, if you have something in a language is of length 0, then it could be an empty string. Okay, so this is this is an example for length 0 string. Okay, so again, what is the example for length 1 string? Length 1 string. For length 1 string, so what are the possible combinations? So we have two alphabets here. So this is one string, this is another string. So the length is 1 for each respectively. So this is example for length 1 string. Okay, this can be equivalently, A comma B can be equivalently represented in the form of, so this is language. So if you want to represent this as a regular expression, then you can represent them as A plus B. Okay, you can represent them as A plus B. Okay, so what we are doing is we are actually performing a union here of A and B and changing the braces to parenthesis. The fourth example here that we are going to see is of length 2. So length 2, what is the length 2 string here? So you can take all possible combinations of this A and B. So what are the possible combinations? You can get an AA, AB, BA, BB. So no other combination is possible. This is a language where each string is of length 2. Now how to represent this in the form of regular expressions? So how to evaluate this? So that we'll see next. So we have AA, AB, BA, BB. So if you are representing this language in terms of regular expressions, so in which case we'll be replacing the this braces by a parenthesis, and here and then we will be using the union operator. Okay, so AA plus AB plus BA plus BB, right? So here we are taking the common element out. If we take the common element out, the A into A plus B, then plus B into A plus B. So it will be A plus B, A plus B. Okay, so this language when represented in the form of regular expression takes this form, A plus B, A plus B. So this is the language example for string length 2. So similarly for string length 3, what are the possible combinations that we'll be having? Will be A, B. Okay, so how many combinations we'll be having? We'll be having 2 power 3 minus 1, 7 combinations we will be having. Okay, now so what will be the regular expression equivalently for that particular language? See, if you are having 2 length string language, it is A plus B, A plus B. So for 3 length string language, it will be A plus B, A plus B, A plus B. This will be the corresponding regular expression for a 3 length regular language. Then what is an example for a language where all the strings have at most one length? Okay, so string of length at most 1. So it could be something like this empty string, then A comma B. At most 1 means what? Not more than 1. Okay, L is equal to sigma AB. So at most 2 means L is equal to sigma A B, then you have AA, AB, BA, BB. So these are all the elements. So this can be represented as, in regular expression you are representing this as epsilon plus A plus B, and here this can be represented as epsilon plus A plus B, then epsilon plus A plus B. Okay, 2 epsilons. At most 3 means obviously the regular expression will be something like epsilon plus A plus B, epsilon plus A plus B, then epsilon plus A plus. 3 times it will be repeated. Okay, so these are some of the examples for regular languages which takes string of length 0, of length 1, of actually first it takes string of length null, then length 0, length 1, length 2, length 3, and at most 1, at most 2, at most 3, etc. Now we'll solve some examples. Okay, the first example is L of 0. So here we have a language like this, L of 001. So what are the possible strings that can be derived from this language? It is simply 001, simply 001. So here this is a regular expression, so we are representing the regular expression of the language, so representing it by parenthesis. If you are writing the strings of the language, you have to represent it by, as I already told you, you have to represent it by flower brackets or braces. The second example, let us see L of 0, 10 clean closure star. Okay, so L bracket, this is the second example, L bracket 0 plus 10 star. So how to first how to process this, how to interpret this. First, if you perform a union of two different union of two different operands, so first write down all, first solve each operand. So here the first operand is 0, so there is no operation as far as this 0 is concerned. I just write, so when I form in the language, I just write down the 0, and this 1 is mandatory. Okay, that is, again I write the 1 here, and the 0 is consists of a clean closure, which means 0 or more occurrences of 0. So if 0 isn't present, I'll simply get a 1. If 0 is present, then I'll get a 1 0. If 0 is present 2 times, I'll get a 1 0 0, etc. So this is the language, corresponding language. Okay, I'll repeat once again. So union of two regular expressions, okay, present in the language. How to solve it, how to evaluate that expression is, first evaluate each expression separately and you combine them and write. Combine is just putting together within a single set or within a single place. So 0, you cannot evaluate the 0 just writing the 0 here. Here if you see, we got a 1 0 star, this 1 is mandatory, so I just put a 1. And whether a 0 should be present, yes, it can be present or it may not be present, and if it is present, can be present any number of times. So I just write the 1 here, and for the second operation I just put the this is 0 occurrence of this is 1 occurrence, 2 occurrence, and so on and so forth. This is the language formed because of this corresponding to this regular expression. Now we'll see yet another example. L of 0 star 1 0 stars. This is another example. Now if you take this example here, we say there's a concatenation operation. So how to perform the concatenation is first evaluating these two operands separately, okay, and then performing a combination, that is you're making a mix of all the combinations, just like the cross product that we do in the set. Okay, so it is similar to the cross product. Right, now how to evaluate 0 star? So we know that 0 star means 0 or more occurrences of 0. So first it could be the empty, then 1 0, 2 0, 3 0, etc. And what about this 1 0 star? 1 0 star, here 1 is mandatory again, so I write the 1 here, and 0 could or could not be present as in the previous case, so I write 1 1 0 1 0 0 1 0 0, etc. Now what I'm going to do is I'm going to do a cross product of these two evaluations. So when I do a cross product of all this with this one, what I get, so 0 1, then so this is 0 1. This empty is there, right? So first empty 1 will give you a 1, then you have a 0 1, okay, then you have 0 1, then 0 1 1 0, 0 1 0, then you have 0 0 1 0 0, etc. Then I'm sorry, just a second. So when you are doing a cross product, what you are doing is you're combining epsilon with every single element in the second evaluation. So sigma 1 will give you, it's not sigma, it's epsilon 1 will give you a 1, epsilon 1 0 will give you a 1 0, epsilon 1 0 0 will be 1 0 0 1 0 0, okay. Then here next 0 with all these elements. So 0 1, you'll get a 0 1, then 0 1 0, then you'll have a 0 1 0 0, then you'll have a 0 1 0 0. Then you're combining 0 0 with all this. So similarly, it's going to be an infinite set. Why it's an infinite set? Because we have a clean closure, which means any number of repetitions or any combination of these elements is possible. Okay, so this is the corresponding language to this regular expression. Okay, so here concatenation means we are finding a cross product of these two evaluations. Okay, now next we'll go to the next language, next example, L sigma sigma stars, L sigma sigma star. So you have to understand here the sigma consists of all the elements in the language. If sigma is equal to a comma b, and actually you're making two repetitions of a comma b, which means like something like a comma b comma a comma b the whole star, right? Okay, something like this. So here we are not separating it by because we don't have the, we are only having the concatenation operator. So what we are actually getting is AB for the sigma, another AB for the sigma, the whole star. So again, if I do a clean closure operation, what is the language I'll be getting? Empty, AB AB, then AB AB, sorry, AB 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 AB. Okay, then AB AB. So this is 1 repetition, 2 repetition, then 3 repetition, then 4 repetition, and so on and so forth. Okay, so ultimately you will be landing in strings of length or even length. Okay, so the language will be consisting of strings of even length. So here the string is of length 4, here it is 8, here it is 12, next it's going to be 16, and so on and so forth. The strings present in the language will be of even length. So that is this as far as this example is considered. The next example that we are going to see is L double parenthesis 0, again a parenthesis, 0 plus 1 close parenthesis, star, and close parenthesis. Okay, so start with the innermost loop. So here what we get is 0 0 plus 0 1. So when I remove all the parentheses, I get, this is the final language that I get. Now how to, so final expression and how to derive the strings for the language. So here this means here you have to note a point, 0 plus 1 the whole star mean any combination of zeros and ones including the empty set, empty string, comma, 0 1, or it could be 0 1, or even it could be 1 0 also, 1 0 0 0 1 0, so any combination. Okay, so when I evaluate this, what is the answer I'll be getting as, what is the language I'll be getting as an empty string first, then 0 0 0 0 for any number of times repetition, or 0 1 0 1 any number of times repetition. Okay, or a combination of this, 0 1 0 0 also I'll be getting. Okay, 0 1 0 0 0 0 also I'll be getting. So any number of zeros and ones will do. Right, so this is the language that I am getting. So for this expression, this is the language. Okay, right, so if you see the next example, so the next example here is L of 0 plus epsilon, then 1 plus epsilon. Okay, here again we do a just like algebraic expressions, we do multiplication. So in order to remove the parentheses, so 0 1 we write it like 0 1, okay, plus empty into 1 is 1, then plus empty into 1 is again a 1, then empty into empty is a empty. I hope this is clear. 0 1 empty 1, 0 empty empty empty. So okay, actually this is 0 empty, so you get a 0 here, right? 0 1 1 empty, then 0 empty empty empty. So this is, so if you write this, so when you remove the union operator, what you get is 0 1 comma 1 comma 0 comma. So this is the language, this is the strings that you derive from this regular expression. Can you follow? In order to remove the parentheses, you just have to make and just have to combine just like your arithmetic expressions. So what I get, 0 1 empty 1, 0 1, then empty into 1, then 0 into empty is 0, then empty into empty is empty. And after removing the union or the plus sign and replacing with the comma, and this is the final set of strings for the language. The next example is L of So this symbol stands for empty set. So L of empty set, this is a regular expression. So what is the language in turn you get is, okay, so this is the language for this expression. And what other example do we have? Let me see, we have another example. Yes, as far as regular languages are concerned, when you concatenate a regular expression with an epsilon or an empty string, the resultant is a regular expression. This is one point to be noted. The second point to be noted is when you union a regular expression with a null or an empty language, the resultant language is a regular language. Okay, so here or I can say that we are not talking in terms of language only. This represents empty language, R represents empty regular expressions. So when I perform a union operation of a regular expression with an empty language, the resultant is also a regular expression. The third point to be noted here is the regular expression, when you union it with a epsilon or an empty string, it may be equal to the regular expression, or it may not be equal to the regular expression. So R plus epsilon can be or cannot be equal to a regular expression. That is, when you are adding an empty to a regular expression, it can equal the regular expression in some cases, or it may not be equal to the regular expression. And the next point is, when you concatenate an empty language with the regular expression R, we may get a R, that is, we may get the same R if R itself is an empty set. Okay, if you have an empty language and you are concatenating with a regular expression R, you may get the same R only when R is again an empty set. So again the resultant will also be an empty expression. Okay, so can you follow? So here the terms are misleading, so you shouldn't confuse between the terms. So this stands for language, sometimes this stands for set also, language or set, whereas R stands for expressions. Okay, so if the regular expression itself is null, then if you concatenate with an empty, another empty or null set or a null language, the resultant will be another null expression or a null set. Can you follow? So these are some of the examples as far as regular expression is concerned. I hope you are clear. So in the next sessions to come, we'll be working out some other problems in this topic. Thank you.